So first we're going to talk about thermal energy. Thermal energy is the amount of heat and motion that a substance has in its molecules. Okay, so the amount of heat and motion a substance has in its molecules. And so thermal energy has to do with the substances themselves. Everything in the world has a certain amount of thermal energy associated with it at any given time. And it depends on its environment and its own ability to retain thermal energy. Things like metal give off their energy very easily. That's why in a room, metal is usually one of the coldest things because it gives its heat away very easily. Whereas things like the thermoses, they're designed to have things that retain their heat very well in order to keep things a lot hotter for longer. So thermal energy is connected to phase changes. Okay, so we're going to talk about phase changes as well. So this one, you don't have to write phase change in your notebook, but phase change is when we go from one state of matter to another. And so we're going to talk about the different phase changes today. Up here, so up here I have H2O, that's a substance of water, in 3 different phases. There's solid, liquid, and it's steaming a little bit, and so it's the gas form. So I have H2O in all 3 phases, solid, liquid, and gas. And as we change between those different phases, we have different words that we use. You're probably familiar with most of them. So as this ice turns into, as a solid turns into liquid, we call that melting. So these ones I do want you to put down. So melting, solid to liquid. And then the reverse of melting is freezing, which is liquid to solid. Then as we have water gaining thermal energy, so this heater right here is giving the water thermal energy. In this cup, thermal energy is being added from the room. So the room is warmer than the ice, and thermal energy always flows to anything that's colder, anything that has less thermal energy. So the room is actually becoming slightly, minusculely colder because I have this ice in here, because its heat is flowing into the ice. This heater is pushing heat into this water, causing it to boil. So boiling is another phase change. Okay, and that's liquid to gas. The opposite of boiling is condensation. Which is gas to liquid. And we can actually see condensation on this right here. You notice on the side there's water droplets. Those water droplets are because the steam of the water hitting the top of this glass is much hotter than the top of the glass is, and so that steam loses its thermal energy to the top of the glass and comes back into liquid. You probably see it quite often when you are boiling things on the stove above whatever you're boiling. Little droplets start to form. That's the gas that you just made losing its energy and becoming liquid again. You also may see it, like if you're ever at a restaurant and they give you a cup full or a glass full of ice, and over time lots of water gets on the sides, and that's why they usually put it on a coaster or on a napkin to catch all that water. That's the air in the room losing its thermal energy and becoming a liquid on your glass. And so that's another example of condensation happening. So we've got boiling, condensation, and then for liquid to gas, we actually have a second thing that can happen, and that's evaporation. That's liquid to gas as well. Evaporation only happens on the surface of the liquid. So if I were to take a little bit of this liquid and put it on the table like that, eventually it will turn into a gas. But it's not because thermal energy is being added to it, it's because the surface of the liquid is just slowly turning into gas. Some liquids can do that, others cannot. But evaporation is only on the surface. So add only on surface. If you have a pot of water, the liquid on the bottom of the pot will never evaporate. It will always be from the top of the pot. Okay? So evaporation is liquid to gas only on the surface, and you do not have to add heat in order for it to happen. Water does not have to be boiling for evaporation to happen. Then we have one more, which is sublimation. I was going to bring my cooler so we could have dry ice and I can show you sublimation, but I forgot my cooler, so I apologize. But maybe I'll bring it Monday. So sublimation is solid to gas. When a solid turns to straight to gas, it never goes to liquid, it just goes straight to gas. That is sublimation. So a lot of these you're probably fairly familiar with, and this is just kind of the formalization that this is what we call them. We call them a phase change, and it's one state of matter moving to another state of matter. Solid to liquid, liquid to gas, or the reverse. And it all is driven by thermal energy. As you add thermal energy to substances, they will tend to go towards the gas state. As you take thermal energy away, they will tend to go to the solid state. Some substances are harder to get into one of the states of matter than others. For example, carbon dioxide, which is what dry ice is made out of, has to be at like negative 200 degrees Fahrenheit before it will go to a solid. Whereas water only has to be at 32 degrees Fahrenheit to go to a solid. So different substances take or have to give away a lot more energy to become solids, and other ones, not as much energy in some solids. Metals, in order to get them to liquids, often, depending on the ones you have to get upwards to like the 2,000 degrees Fahrenheit to get them to metals, or get them to liquids. And so it really just kind of depends on the substance and its molecules and the way that they're formed. What we're going to do today is you'll have a worksheet on the iPad that will give you different scenarios, and you have to say what phase change is happening, what state did it start in, what state did it go to. Yes, Braxton? In a second. But do we have any questions about these phase changes before we get started? Okay, we all have them down for reference. Okay, go ahead and get your iPads.